Hi everyone. I want to go over some of the assignments from last week to help you along because I know some of them were pretty tricky. So first we're going to go to the IXL website and the section that you needed to do last week, which was on factoring, and practice some of those problems together. And then I will go through the assignment, which was solving quadratic equations by factoring, and we'll do some of those together on this video. I'm going to go to the IXL website and share my screen with you. Okay, so here's the IXL website. You go to learning and you get all these different levels. Yours may look a little bit different, but we want that level K was assigned last week, and it was to do sections AA. AA is all about factoring, and I asked you to work on section AA4, 5, and 6. So let's take some problems from section 4, AA4. So let's click on that. All right, so I'm just going to write down some of these examples. It says n squared plus 16n plus 15. I don't know if I can go on to a different example. Can I go to a different example? Let's go back and see if I can get a different example. So that one's d squared plus 8d. These go by pretty quickly. Let me see if I can get another one here. D squared plus 8d plus 15. So d squared plus 8d plus 15. I'm going to pick something from the other section. This one has a leading coefficient. It's 2x squared plus 7x. What was that? 2x squared plus 7x plus 5. Let's see if we can get another one. Okay, so this one was 6u squared minus 11u plus 4. And then let's take an example of the special cases. This was k squared minus 25, or 25v squared minus 49. Okay, so I've written those 6 examples down. Let's go to the document camera and work through them. So here are the 6 examples that I took from the IXL website. All right. So we'll say this is example number 1, although it's from AA section 0.4, I think that one was, and then the second one was as well. 3 and 4 were from AA 0.5, and then 5 and 6 were from AA 0.6. And these were all in level K. Okay, so let's practice how you do these factoring problems. The first 2 are trinomials that have a leading coefficient of 1. So these are a little bit easier to do. You can guess and check. What we want to do is figure out what are the factors here such that they multiply to give us 15, but add to give us 16. So I know I'm going to split the n squared as n and n, and I want to think of 2 numbers that multiply to give me 15, but add to give me 16. And so you might think right away it's 15 and 1. That's true. So those are our 2 factors, n plus 15 and n plus 1. You can check. The outsides is 1n, multiplied to give you 1n. The insides multiply to give you 15n, and altogether those add up to 16n, and that checks. So these are our factors. Number 2 is kind of similar. We want to now think of 2 numbers that multiply to give us 15, but add to give us 8. And instead of n's, we have d's. So I'm going to put d here and d here. 2 numbers that multiply to give us 15, but add to give you 8. That would be 3 and 5. Okay, so those are our 2 answers. Those work. The next one is when you have a coefficient that's not 1. So that makes it a little easier. I mean, not easier, it makes it a little harder. So what we want to do is use that X method to factor these kind of problems. And I would like to see this method or some kind of work that you use to factor and not just come up with the answer off the top of your head. So to use X method, we want to multiply the first and the last, and that would be 10 in this case. And then the middle number goes here. So I want to think of two numbers that multiply to give me 10 and add to give me 7. Well, I know that 5 and 2 work. And so I rewrite this as 2x squared plus 5x plus 2x plus 5. So I'm just replacing the 7x with 5x and 2x, as I know those will multiply to give me 5 and add to give me 7. The reason I replace them is now I can factor these by grouping. And I see that x is common to these first two, and that leaves me with 2x plus 5. Nothing's common here, so I just write 1, but then that leaves me with 2x plus 5. And then that equals 2x plus 5 is common to both of these, 2x plus 5, and that leaves me with x plus 1 as my other factor. And those are my answers. You can multiply this out using the distributive property twice. 2x times x is 2x squared, 2x times 1 is 2x, and then 5 times x is 5x, and 5 times 1 is 5, and you'll get back to what you started with. Let's try that example here, number 4. Okay, so I want to multiply the first one and the last one. That number goes here, 24. And then I want to put this number here, -11. So I want to think of two numbers that multiply to give me 24, but are going to add to give me 11. Now, because this multiplies to give me a positive number, that tells me that the signs have to be the same. And because they add to give me a negative number, I know that both of these signs have to be negative. So basically, I want to think of two numbers that multiply to give me 24, but would add to give me 11. And the answers are 8 and 3. So then I rewrite this 6u squared. In place of 11u, I'm going to write -8u minus 3u, and then I'm going to write plus 4 here. And then I factor by grouping. So this I know there's common 2 and u. And I bring that down and I factor out the 2u from those two terms, and that leaves me with 3u minus 4. Over here I'm going to factor out, there's nothing common, but I know there's a negative there. So typically when there's a negative there, I want to factor out a -1. If I factor out a -1, that leaves me with 3u, and then I have a -4. Because I'm factoring out a negative, I have to multiply back in a negative in order to get this to be a +4. Notice then I have 3u minus 4, which is common to both of those pieces, and that leaves me with 2u minus 1. So those are my factors. All right, the last section is on special kinds of quadratics. Here we have the difference of two squares. So we set this like this. All right, I want to factor the k squared as k and k, and then I want to think of two numbers that multiply to give me a -25, but add to 0 because the middle term in this one has 0. It's gone to 0 because it's not there. So what two numbers multiply to give you a -25 but would add to give you 0? Well, they're going to be opposites of each other in order to give you 0. And so we have 5 and -5. And those are our answers there. This one, kind of similar, difference of two squares. I want to factor 25, v squared as 5v and 5v. I want to factor 49, 7 and 7, and I make one of these positive and one of these negative so that the middle term cancels out. And that's that one. If you still have questions on factoring, there are lots of videos. I'll try and attach another video that you can watch, maybe from Khan Academy, that might help you. I also want to go through the assignment from last week to do some of the problems. So let me just pause this for a minute. All right, so here's the worksheet that you had to do last week, and it is to solve the equations by factoring. So I'm going to go through some of these to help you get started in case you're stuck. Let's go through number 1. So the first step to solve by factoring is to get it equal to 0. This one already is equal to 0. So then the second step is to factor. Okay, so I want to think of two numbers that multiply because this has a coefficient of 1. This one I can just guess and check. two numbers that multiply to give me 21, but add to give me 10. Well, I know that that's going to be x plus 7 and x plus 3. They multiply to give me 21, and they add to give me 10. So once I have that verified, I've checked it, then I'm going to separate each factor and set each factor equal to 0, and then solve. So I subtract 7, and I get x equals -7 as one of my answers. I subtract 3 here, and I get x equals -3 as my other answer. All right, let's try number 6. So in number 6, we have not a trinomial, but we want to still solve this by factoring. So let's see what we would do to factor this. I know that there is a common factor between these two terms. Can you see it? Yeah, v. So v gets factored out, and then I'm going to write down what's left in the parentheses. If I factor out a v, I have v minus 5 left over. This is equal to 0. And so I say v equals 0 or v minus 5 equals 0, and I add 5 to both sides. I get v equals 5. This one's already solved, like that. Okay. Let's take a look at number 4. Number 4 is, it looks pretty tricky, but you do notice there's a common factor. Maybe if you notice the common factors first, always look for common factors first, and then see what you can do from there. It might make it a little bit easier. So I can see that 4 is a common factor to all 3 terms. So I'm going to factor that out first. If I factor out a 4, I have x squared left plus 5x minus 6. Then what's inside here is just a trinomial that can also be factored. So I'm going to bring this down. And I'm going to figure out what two numbers multiply to give me a -6, but add to give me a +5. So I'm going to put the x and x here. Two numbers that multiply to give me a -6. One has to be negative and one has to be positive in order to get a negative answer. And I know that 6 and 1 would work. If I put the 6 to be positive and the 1 to be negative, they're going to multiply to give me -6, and they're going to add to give me a +5. Okay, so I've checked it. Now I'm just going to write the factors equal to 0. I can disregard the 4 because basically what I could do is divide through by 4, and I would have these two factors equal 0. 0 divided by 4 would still be 0. So that makes this simpler. I'm going to add 1 here, and I get x equals 1. I'm going to subtract 6 here, and I get x equals -6. Okay, so that is 3 examples from the first page. Let's try one of the examples on the second page. Okay, I'm going to take example 13. This is one of the harder problems. 13 and 14 are the hardest. So let's take a look at this. First of all, it's not set equal to 0, so that is one of the things you need to do. Get everything to one side, and I would recommend getting these two terms to this side so that this stays positive. So I'm going to subtract 22r minus 22r, and I'm going to add 24 plus 24 to both sides to get 0. Okay, so I've subtracted 22r from this side, which makes it cancel there, and it comes over here, and I've added 24 from this side, which makes that goes to 0, and I have this over here. So looking at, is there a common factor here? There's not. So this is one of those problems where you have to use the x method to factor it. So over here on the side, I'm going to set up my x. I'm going to multiply 3 times 24. 3 times 24, let me get my calculator out. 3 times 24 is 72. And I have -22 is what I want to figure out. So what two numbers multiply to give me 72, but add to give me a -22? Because this is positive, I know the signs have to be the same. And because this is negative, I know they have to both be negative. So let's think, 72. I know it's 3 times 24 because that's what I used to multiply. And 24 is 3 times 8. 8 is 2 and 4, and 4 is 2 and 2. So these little leaves at the end are my prime factors. I want to try and put them together in a way that gives me two factors that will add to negative 22. So 9 times 8 is not negative 22. I mean, 9 here and 8 here are not going to be, although they do multiply and give me 72, they're not going to give me 22 when I add them. So that wouldn't work. 9 times 2 is 18. Oh, and 18 and 4. So these three to go together to make 18, and those two go together to make 4. So I know that 18 times 4 is 72. If they're both negative, it's still going to be positive 72 when I multiply them. And when I add them, it's going to be a negative 22. So that's how I'm going to replace this number in the middle here. I'm going to rewrite 3r squared and rewrite this as minus 18r minus 4r plus 24 equals 0. Then factor by grouping. 3r is common to both of those two terms here. If I factor to 3r, then I have left r minus 6. Over here, I'm going to factor out what's common. And notice this is negative again, so I'm going to factor out a negative 4. That leaves me with r minus 6. So that r minus 6 is common. R minus 6 comes down, and what's left is the 3r and the minus 4. Okay, so I set each one of these equal to 0. And I get r equals 6. And if I add 4, 3r equals 4, divide by 3, and I get r equals 4/3. So I'm going to circle my answers. I did provide you with answers, so you can check if you're right or wrong. But I also need to see the work. In order for you to get full credit, you need to show the factoring, and you need to show that you're setting each factor equal to 0 and solving the little equations to get the full credit. Okay, so hopefully this will help get you going a little bit further on this assignment if you got stuck. If you have any more questions, please ask, send me an email, or we'll try and get together in another Zoom meeting. Talk to you later. Bye-bye.